Everybody back and ready?
I think we're all ready to roll. I'm pretty excited about this next topic. You want to introduce Zach?
Yep, can do. So, as I said before the break, next up we have Zack Allen, director at Datadog. He's going to be talking to us about some trends in detection engineering. I'm personally really excited about this section. I want to see what he has been seeing, what he's comes up with. I think overall it'll be a cool talk.
Agreed.
As always, if you guys have questions, anything like that for the speaker or for us, drop them in chat so we can make sure we can relay them.
Hey, Zach. Thank you.
Hey, thanks for having me. How are you doing?
Yeah, it's been great. We've had a good morning so far. Looking forward to this topic.
That's good. That's good. Okay, I'll try to do my best here. And it looks like I can see the live stream. You can see my screen. So I'm going to just go ahead and get started here. Hi, everyone. My name is Zack Allen, and today I'm going to talk about detection engineering trends. And I'm going to do a quick who am I and jump right into everything. So I've been in the security industry for about 12 years. I used to work at the organizations at the top there on the right. I went to school, the schools in the middle. So undergrad, I went to RIT. So if there's any Tigers in the chat, how's it going? Got my MBA at NYU Stern. I'm currently the Senior Director of Security Detection Research at Datadog. And I can confirm that is a picture of me, although I look a lot more relaxed because I'm in the south of France and I probably have a lot more sleep than I do now because I have 2 small children. So let's jump right into it. So here's the outline. I want to talk a little bit about how I kind of arrived into the detection engineering field and what got me there. Talk a little bit about the trends I've been seeing and observing over the last 2 years, and some takeaways that everyone here can hopefully bring back to them, bring back to their jobs after this talk. So, how do we get here? About 2.5 years ago, I started a new position here at Datadog. And so my goal, and I was tasked with, was booting up a new threat detection org. And so what I know what I needed to do was that I needed to make do with what I have. I had a certain amount of capacity, I had a certain amount of budget, and I needed to scale up and build a bunch of rules to go and find bad stuff on behalf of our customers. And I thought detection engineering would probably be the golden path here. So I did what any good researcher does. They go on social media, look up discussions, look at links and things like that. But I really needed something more in terms of a daily read, especially as the field started to evolve. It's been around for a few years, and I just wanted to make sure I could stay abreast of all the trends that were happening. I looked at academia. I looked at other security newsletters, YouTube. They had some information. It was scarce and it was spread apart across all these different types of mediums. So again, I do what any good security researcher does. They ask questions. And so I asked a question on Twitter. I think this was before it was changed to X, or maybe right before. Is there a newsletter or is there an aggregation source for this field? It seems like a great topic. It seems like it's emerging. There's a lot of great research coming out on blog posts, YouTube, as well as conferences. It would be nice to have it in one spot. And I basically asked, should I do this? And should I create that source for folks? And about 5 days later, I started this Substack newsletter called Detection Engineering Weekly. This is issue 1. And the basic premise behind it was that every week I would go to all these different spots. I would aggregate all these articles and research and videos and podcasts and open source repos. I would perform my analysis on it. And I was already giving it to my team and I was already talking about it at work. Why not just put it on a newsletter? So 65 weeks later, I have 65 issues. Actually, number 65 is coming out tomorrow. And close to 8,000 subscribers later. I really got lucky, I guess, in terms of my timing. About 650 articles from my own analysis on different things within detection engineering. I looked at hundreds of open source repos. I've analyzed hundreds and hundreds of hours of podcasts and YouTube videos. And these are just things that make the cut to go on the newsletter. So I may not be the best at detection engineering or the most knowledgeable, but I'm probably pretty high up there just in terms of consuming content. And so the inspiration for this talk was, hey, since I've been looking at this stuff for a good amount of time now, what are some of the trends that I'm seeing both in research, what people are putting out there, tool sets, news, and just kind of some of the lessons learned I had when building up this at my company. So trend 1. Detection engineers are experts in more than just security. When I first got into security, that's all I wanted to dive deep on. And then I started to realize that when I brought in more and more different parts of like professional experience and what other fields are doing, I just got, for the most part, better at my job. And so when it comes to threat detection, this kind of has the same thing, right? So I'm going to give a quick TLDR of a threat detection system. It probably hasn't changed in the last 2 decades, which I think is also an interesting point within itself. But let me explain in terms of how it's the culmination of all a few fields. So whenever I think of a threat detection system, I think of telemetry, a source, a log source. Maybe those logs are on host, network, traditionally, and then it starts moving to the cloud, SaaS, identity, things like that. And they all have different formats. They all have different ways to kind of express certain pieces of information. So you need to build a system to transform that data, or people call this an ETL system: extract, transform, and load. This isn't a security thing. This is actually a software engineering thing. It's a pattern that's been done many, many times throughout the decades. And so this is kind of like the first component that I started to notice, was that my detection engineers that I tried to hire needed to be pretty good or aware of software engineering principles and taking advantage of these systems, and at times building these systems. Now, those logs need to go somewhere. And typically it goes into a tool like a SIM, and that SIM has a corpus of rules that when those rules are ran, they'll perform a search query. Maybe it'll be streaming for detection as code. Maybe it'd be more of like a data lake like SQL. And those rules look for the bad guys in the log sources that you see to the left. This hasn't changed in threat detection. Security analysts are the bread and butter here. It's that subject matter expertise that we need to hire for. But what you're starting to see is that now you need to have these software engineering components in some ways to kind of understand what you're working with and what you're dealing with, so you can go talk to those teams or build the systems yourself. Ideally, you have a set of rules that are accurate. For the most part, 2 things happen when a search is ran and results are found. An incident is going to occur, or it's going to be business as usual. This is fine for a small corpus of rules, but as you start to expand this more and more and more, you start to realize that not all rules are created equal, and it's actually really tough to measure capacity and cost of these certain rules. And so one way you can kind of take advantage of dealing with this at scale is statistics. And so having and hiring for folks that have an awareness in all these 3 things, maybe they have specialty in one versus the other, but having a good mix between these three things has been really beneficial for hiring, and has also been beneficial for building a detection program as a whole. So we're going to go into statistics a little bit more. I saw Jake was talking about a lot of mathematical related things related to AI, and I was really excited about that. So y'all aren't escaping math just yet. So let's get through this. Alert fidelity, I just talked about it. It's being treated as a data science problem rather than a security problem. So what I mean by that is, when you think of a threat detection system, you can kind of look at it in this model. So this is a model published by the Spectre Ops folks, specifically Jared Atkinson. And he talks about in this blog post, which is linked at the bottom there, the funnel fidelity. In the ideal state, you collect telemetry, you run detection over it, you triage, you investigate, and then you remediate a certain amount of incidents. You'll notice the numbers are basically being reduced by factors of 10 as you move left to right. And he says this throughout the blog post: don't clog the funnel. This is where I think statistics and a general application of statistics for detection can be really beneficial, so you don't clog the funnel. So I think it's the great communicator. So what you're looking at here is called a confusion matrix. It's just a fancy way of saying it's a box with 4 labels: true positive, false negative, and true negative. And what you can see here is that a lot of folks, when they talk about rules, they talk about the 2 boxes at the top: true positives and false positives. And they're leaving out half the labels that kind of make statistics what it is, right? And so I want to talk a little bit about how you can use ratios of these 4 different types of labels to reason about how you build rules. I think one of 2 really useful ratios in data science, and I think is really applicable here to detection, are precision and recall. What you're looking at on the left here is basically a Venn diagram with false negatives, true negatives outside of the circle, true positives and false positives inside the circle. We want to increase the true positives inside, decrease the false positives inside. We want to keep the true negatives where they are, and we want to bring the false negatives in. And so when you think about this from a ratio perspective, you can go and actually measure how many retrieved items are relevant. This is the precision ratio. So you take the green circle, the true positives, and you divide it by the sum of the true positives and the green signals, as well as the false positives on the other side. And what this basically shows is, when I alert on something, Is it something that I need to investigate? And is it something that I think is not a waste of time? Full pause there. Recall, on the other hand, is when I'm alerting on things, what are the things that I'm missing? This helps factor in the false negative problem with a rule. And so using these two things together is a really powerful tool to build out a high fidelity rule corpus, basically. And so let me get into some examples here. So what you're looking at is basically a set of 22 events. Of those 22 events, there are green things which we want and red things that we don't want. So the green circles, we want alert on those. The red circles, we want to keep away from the alert. That decision threshold is basically a rule. You can think of it as like a search query in Splunk. And if results come back, the results are on the right, and those are things that we should investigate. Here's my confusion matrix: 5 true positives, 5 green circles on the right, 1 false positive, 1 red circle on the right, 3 false negatives, 3 green circles on the left, 13 true negatives, 13 red circles on the left. If I compute the precision ratio, you'll notice that it's true positives over the sum of true positives and false positives. 5 over 6, 83%. Okay, this is pretty good. For every 5 alerts we're looking at, or sorry, 6 alerts that we're looking at, one of them is something that is a false positive. But this doesn't tell the whole story. If I go and compute this again using recall, you'll notice that that percentage drops pretty heavily. So every time we're alerting, we're leaving out at least 3 false negatives, or 3 things that are security incidents. And this could be a disaster depending on the rule and the thing that you're looking for, right? But let's take this a little bit further. I'm going to move that decision threshold to the right, and I'm going to make a highly precise rule. So as you can see, the search now returns 4 green circles on the right and nothing on the left. And so if I compute precision again, I have a great rule, no false positives. So this is going to be awesome. I'm going to deploy it. People are going to be really happy. When you compute the recall, it tells a different story. It basically loses half of that, so 50%. And what this means is that although we're not wasting the SOC's time and they're finding a lot of things, we're probably going to spend a lot more money and waste a lot more time because we're dealing with these breaches later down the road because we missed 4 of those false negatives. And so the question becomes, well, what percentage do you want? What percentage do you need? Another post by Jared, he talks about the detection spectrum. And the basic premise behind this is that detections can be broad or brittle. This is really just recall and precision. And so if you want high precision, that means you'll have a low to 0 false positive rule with high false negatives. If you want something with high recall, it'll be a high false positive rule, but you're not going to miss anything because it's going to be low false negatives. So what would you rather have? Well, I have a boring answer here. It depends. It really depends on the rule. It depends on the business needs. It depends on your risk assessment. I think a good way I like to describe the story here is that, let's just say you have rules on critical assets or crown jewels. Maybe you want higher recall. It's okay to waste some time investigating false positives because your org cannot take a false negative that results in a breach. Maybe you have a rule that it's okay if you have a couple false negatives and you don't want to waste the SOC's time. You want it more precise. So it's really a balancing act between all of these things. And my point is, statistics is a good way and a good tool set to use when you're looking at these different types of rules. All right, trend 3. Detection teams adopt maturity models for quick time to value. So for those that are unaware, capability maturity models, they stemmed from government research. I think it was the DoD in the 80s. It's a very DoD thing to build something like this, where basically you have an organization, you map out different levels of maturity that have different milestones on them. And as you progress through the different levels, 1, 2, 3, 4, et cetera, your organizational effectiveness goes up and your process sustainability goes up. Same with your project repeatability. What's great about this is that there's actually been a lot of great public research in the detection engineering field on maturity models applied to building an org and building processes around threat detection. So I'm going to highlight 2. Hyder Dost, who's on the right there, he wrote a blog post, which is on the bottom, that talks about the threat detection maturity framework. And so there's 5 categories of maturity. I couldn't paste the whole thing here, so I just took a slice. And so what this slice shows is a lot of descriptive outcomes of maturity rather than prescriptive. So think of it as something like, I want, rather than a recipe to make something, you're just kind of describing something that you really like. So what this basically means is that there's a lot of space to adapt to your needs. So I took out one slice, processes, and I put it here. And so if you read left to right, top to bottom, you'll notice there's an evolution of detection processes here. Formalized development of rules, metrics, partnerships, threat detection life cycles. As you kind of progress through this, your org becomes better and better. This was really, really useful tool when I was hiring for my org. And I've seen a lot of people apply this same tool set or the same framework when they were kind of mapping out the strategy for their detection engineering efforts. Now, if you go on the flip side, Kyle Bailey, I think he's at Google. He made something called the Detection Engineering Matrix, linked at the bottom there. And it is prescriptive rather than descriptive. And what I mean by that is that it says you must have these things in order to achieve this level. So it actually is the recipe that I talked about earlier. He also has categories similar to HIDR, but he has subcategories in there as well. And what I like about this is that if you follow these things, it is pretty reasonable to say that you are maturing your threat detection efforts. And so you can read this again, left to right, up to down. In the SIB subcategory, they talk about outages, they talk about resiliency within your SIM pipelines, very software engineering focused. They talk about latency, and they talk about basically, is your SIM's performance enough so that you can catch things fast enough? And so I thought this was a really cool model to kind of bring in and adapt, because it was a lot more opinionated in terms of what good looks like. All right, trend 4, MITRE ATT&CK. It's number 1, it's the king, but the community also recognizes its limitations. And that doesn't mean it's bad, but there is nuance when you're implementing MITRE ATT&CK. And so I'm going to talk about this specifically when it comes to something called rule coverage. So tell me if you've heard this before, if you work in threat detection. You have leadership sending an email, a Slack message, they're talking to you, they see some attack that's happening in real time, maybe some news site is publishing it, and they ask, are we covered? Do we have sufficient rule coverage? That's a pretty hard thing to answer, right? And so I want to reframe it. For each data source that the detection team is responsible for, do we have sufficient rules that detects the space of possible attacks? So now we're applying that statistics lessons all over again, but it still begs the question, what does sufficient actually mean? So let me get into this a little bit. When you think of a single telemetry source, host, network, cloud, things like that, again, there are basically 2 events that happen, benign ones and malicious ones. So green is benign, red is malicious. You could theoretically catch all attacks in this source if you alert on everything. But because we have capacity and cost to think about, we need to draw lines in the sand somewhere. And that lines in this picture in particular is that dotted lines there. So we'll catch everything in the middle, and we're going to deal with it there. So the question is, do you have enough coverage? Well, this gets a little bit crazier because I mentioned earlier, for each data source, this is 1. When you think of multiple data sources, not only are you worried about drawing the lines there, but you're also looking at the interoperability as well as the boundaries of those data sources and the attackers moving through each one of those. So again, what is the best case when it comes to coverage when you're saying, hey, yes, boss, we're covered or we're not covered? I still think MITRE ATT&CK is the best for this. For those that are unfamiliar with it, it's a great tool to use when you're mapping out the kill chain that an attacker can kind of progress through. Everything from reconnaissance, initial access, moving laterally to impact. There are other models out there like the kill chain that you can use too. Now, if you want to communicate your coverage in MITRE ATT&CK, you've probably done something like this. So this was on the Signal Blur website. Great blogs over there as well. And they have a post talking about getting started with Attack Navigator. And with Attack Navigator, what you can do is create these heat maps. And so if you show this to your boss in terms of your coverage, I don't know if this really communicates are we covered, right? Like what does red mean? What does orange mean? What does green mean? What are the different shades? Is it like green means we have a lot of coverage, red means just enough, white means none? So I saw a really good LinkedIn comment by Joe Slowick when talking about this specific topic. And basically what he was talking about is that people think attack is it's taxonomy, but the field is constantly evolving, that instead it becomes a common lexicon. And I really, really love how precise that is. It is a common lexicon for us to talk through these things. It's very useful, but it's not really intended or desired from its original use case, right? So then the question becomes, how do I answer coverage? It's okay to say, we have really good coverage for this type of attack across like MITRE ATT&CK. That's fine to say. But I also think it's important to really highlight the processes you have to find false negatives. So what is your detection life cycle? What partnerships do you have with other teams like CTI, purple team, red teams to make sure that you have that coverage? Are you doing CTI on your own? Are you doing emulation on your own? Are you detecting drift between these things? All really good points to bring up and say, hey, we have good coverage here. These are the known knowns. And then we're doing things to uncover false negatives or excuse me, unknowns. Okay, trend 5. Teams leveraging detection as code, they lean heavily on DevOps paradigms. Again, we're looking at different fields and we're seeing how we can bring those in to make things a lot better for us in the threat detection space. So detection as code actually has several meanings, and I'm gonna go in detail on one of them. So what you're looking at here is a diagram built by Anton Chuvakin, and the link is at the bottom, that basically talks about how detection as code is modeled. An analyst, some subject matter expert, observes some type of campaign or malware. They write detection code to find it. That's uploaded to a repository, maybe on GitHub, that runs through a CI/CD workflow, continuous integration, continuous deployment, and that gets pushed out to security devices. Now, this is where the split happens in detection as code. Does detection as code mean it's a detection written in Python, or is it more like this general concept of detection as code? We should treat it as code as it progresses through our CI/CD pipelines into devices. I'm going to talk a little bit more about this part, which I find more interesting, and I think there's a lot more research that needs to be done on this specific scenario. So for those that are unaware of what CI/CD is, the basic premise behind it is you have two pipelines, continuous integration and continuous deployment. You take code, you reconcile it to make sure there's no one like writing over each other. You build it on a system. It runs a series of tests. And then if it passes all those tests, it's integrated and then handed off to something that delivers it. Maybe it's to a review stage or a staging environment or a production environment. And so I'm really interested in the testing part because I think it's pretty fascinating to test malware and your response to malware in that fashion. And so for those that are unaware of testing, there's all types of code testing frameworks. A lot of them basically boil down to these three, though there are a few more. Unit tests, if we put the threat detection hat on, code and logic, this is your rule. Is your rule formatted correctly? Is it valid JSON? Things like that. Integration, does the rule load correctly? Does it have the right fields? When it's getting put into something, is it causing any type of regressions later on? And then end-to-end, which I think I'm going to highlight here a little bit more. The cool part about this is like, not only is the code formatted correctly, the rule looks good, it's integrating correctly, but you actually get to see it on the other side. Let's just say in a UI. You know it works because it's tactile. It's something that you can touch and feel in a product. And so what we did at Datadog is we designed an end-to-end testing framework for threat detection rules. And so here's kind of like the premise behind it. We have a sample AWS threat detection pipeline. There's several accounts. They log to CloudTrail. CloudTrail is then added to an S3 bucket. Lambda function exports that to some SIM system somewhere, which ETLs it, which we talked about before, runs a detection rule set on it, and then alerts happen. This is a lot of stuff, and a lot of things can go wrong before the rules are, like any type of telemetry can get to the rules at the bottom right there. So we wanted to solve this by building a framework to do so. And so we built this open source tool called Threat Test. And the basic premise behind it is it's a library, it's a CLI tool. And what you can do with it is you can put this in a CI/CD pipeline on the CI side, the integration side, and say, basically, we're going to define this scenario. And in this particular scenario, in line 3, it's an AWS console login. We don't want administrators specifically or anyone logging into the AWS console. Maybe we have a separate workflow for that via the CLI. We're going to detonate a scenario. So we're going to use something called Stratus, which is kind of like Atomic Red Team, but for the cloud. And we're going to emulate initial access to an AWS environment and console login without MFA. And we're going to expect at the end of this test that we're going to get an alert in the Datadog SIM called AWS console login without MFA. We'll wait 15 minutes or so. And then at the end, we're just going to see, did it alert or not? And we're going to run that assertion. What this does under the hood is it'll actually warm up an environment, a test environment in AWS, boot up all the infrastructure, make all those different connections that you see right here, shoot off an attack, run it through everything from account to trail to bucket to Lambda to logs, parsing, all the way to alerts, and then wait for that alert to happen. And if that happens, then we pass the test. If it doesn't happen, we can go and investigate a little bit more. So that concludes my presentation. I told myself I could try to get this done in about 30 minutes, and I think I hit it for the most part, but I have some key takeaways just in case you fell asleep, maybe during the statistics part, or just in case you want to get like a good wrap up of everything here. So I have 3 key takeaways. First key takeaway, detection engineering. It's the culmination of years of work in the industry, adapting to a massive scale up of data sources and threats. I talked about this earlier. Host logs, network logs, that's probably something that we all trained on, or we read blog posts on, we built our labs in. But there's more telemetry coming from those places more than ever. And now you're adding on additional things. You're adding on cloud, you're adding on SaaS, you're adding on identity. So you're looking at those individual sources as well as the interconnection of those sources. And so detection engineering really helps you scale all those different components. And so I talked about this with the 3-legged bar stool. Software engineering is a great discipline to tap into, so you can kind of understand what goes in before SIM and what comes out after SIM and everything in between, right? And I talked a little bit about this with detection as code. So this allows you to write your detections, maybe across a corpus of several hundred to thousands of rules, get them into a system that continuously tests those detections, finds failures before they make it out into production, which is a high cost, and then delivers those things in a way such that you can rapidly iterate and move through it. Second key takeaway, all models are wrong. Some are useful. I think this was especially important for our rule coverage topic, MITRE ATT&CK. It's the best. It's something that I use religiously. My team uses religiously. We've been doing it for a long time. As long as you recognize the biases that something like a model can introduce, particularly a selection bias, where you're really over-tuning for true positives and you're not necessarily looking at false negatives, then I think it's going to be really helpful for you to plug the holes on the false negative side. Threat hunting, emulation, red teaming, purple teaming, CTI, all of those things are useful inputs for you so that you can help cover a lot more of that false negatives. Same, and applying that to statistics overall, like precision and recall, it's really important to kind of look at this at scale, right? Because we have so many things we all need to worry about in terms of incidents and threat actors. Leveraging these in a toolbox is going to be a really useful thing for you and for your organization to be that great communicator that I said earlier, right? So just because a rule is highly precise, it doesn't mean it's useful. Just because you're alerting on a lot of things and some of those things are bad doesn't mean it's not useful. That's precision and that's recall, right? So just consider it and really think about, like, what is this getting me and what is the cost breakdown that I get once I deploy it? And the last key takeaway, study other fields, take the good stuff, fold it into your security program. I think this basically applies to almost all security talks I've seen, especially here. You know, we're standing on the shoulders of giants in many ways. And it's not just security giants of folks that were doing this, you know, since the 80s, 70s, 80s, and 90s, right? It's other fields and other disciplines. Look at how data scientists are managing their models. Take some of that good stuff and integrate it into your security program. Look at how software engineers are building things and scaling things. Take some of that, put it into your security program. There's a lot of things, because we're so integrated into almost all these business processes, it's just a really convenient way to steal the good stuff, so to speak. Okay, that concludes my talk. You know, for any questions, feedback, contact information, there's my email. I didn't change the Twitter logo to the X logo. I don't think I ever will, because I do miss Twitter. That's the link to my Substack and my newsletter. And that's basically it. Thank you for having me.
Thank you very much, Zach. Trey, I know we have some pretty interesting questions, so I'll turn it over to you because I know we've got some good ones queued up.
Yeah, for sure. Thanks for presenting for us, Zach. I enjoyed it, and it was almost hard to keep up because I was taking so many different notes on all of the different little tidbits and blogs and stuff you were dropping in there. We did have a couple questions come up. The first one being, when thinking about the statistical models and the way you were presenting it and showing it, if at all, how do you contextualize impact into those models?
Got it. So when I'm thinking about precision and recall and impact, I'm really thinking about cost, and there's two cost functions here. First is the cost of did a SOC analyst look at this, or did someone respond to this, and then did they say this was useful or not useful? You can basically measure cost there. And it's a lot more precise, and it's probably more realistic, because you basically can take how much time did they waste, and then you just add that up over time, and then maybe say it spent about this amount of money to go and chase down things that don't matter. The second one, it's much, much harder to measure, is that false negative problem, the breach itself. And so it's going to be really hard to say, like, hey, if we don't find what we didn't look for, then it's going to result in like astronomical costs. It's going to be hard to communicate something like that. So for me, I like to best look at this through how much can we take in terms of repairing that cost, like through adding an additional data source or getting a new security product, because you can at least say like that is going to be a lot less than a breach.
Very cool. Solid answer. The next one I have for you is, hey, Zach, we wanted to hear your thoughts on organizations that are still not supporting detection engineering as an individual function group within SOC, CDC, CFC, and they're still getting their analysts to kind of juggle both that operational work as well as this kind of analytical experimental detection engineering work.
My thoughts on this. I look at it as an opportunity. And I look at it as an opportunity because if you're the first one to kind of bring something like this up, that means no one else is really thinking about it. And so I understand it could probably be frustrating where you want to work on something detection related versus going through alerts or responding to things. It can be frustrating, but if you can kind of tell that story and show those metrics that I showed before and how you can reduce costs by doing detection, then I think you could really start to leverage that to build something of your own at your organization. Now, it's going to require influencing, it's going to require building allies and things like that. But I get excited about a situation like this, Brian. So maybe I'm just a little strange, but I think it's something that you could really take advantage of.
Awesome. And last one for you, and then we will let you go. I promise, good sir.
Yeah, no problem.
For those looking to get started in detection engineering, or say trying to start a detection engineering program with their organization, do you have any suggested starting points?
Yeah, at least for the latter, for the program, start with the maturity models and use that to kind of weave that story. If going back to Brian's question, right? Like if you can kind of outline, here's a maturity model and here's where we are, and we're all at the crawling stage or that M1 stage, that's going to be a really important thing that you can show your leadership team. For those that want to get into detection engineering, there are a ton of resources out there. I have them all linked in a lot of my newsletters and a lot of blogs and things like that. There are amazing labs and there are amazing YouTube channels as well of people walking through like a home lab for starting your own SIM and logging to that and responding to things like that. So like I said, there's like that three-legged bar stool. So you want to do enough subject matter expertise and have that good basis in network and host and email security and things like that. Just choose one, but start thinking about what is the infrastructure involved to get behind this. Home Lab is a great place to start. And there are all kinds of things. If you just type in detection engineering on YouTube, you'll find all kinds of things that you can walk through with the person. So
awesome. Well, we appreciate your time, good sir. And
cool.
With that,
thanks for having me.
Much appreciated. With that, we will let you guys go.